Hello, good day. My name is Joyce Jenkins and I'm a member of Group 3 Level 200. Today we are going to be looking at a console to build this application in Python code. Now this application written in Python allows the user to manage tasks by adding them, viewing tasks, marking them as done, or deleting them. The program is structured in a way that it runs the continuous loop, allowing the user to interact with the task repeatedly until they choose to exit. So at the start of the program, the code imports something we call the date time module, which is essential for handling and formatting dates and times. So the main functionality of the code is encapsulated in a function that we chose to call bright, where it begins by initializing an empty list for tasks. This list stores all the tasks, where each task is represented in a list. The program runs in a loop, continuously displaying the menu after each action until the user decides to exit by selecting option 5. So throughout the code, it includes safeguards to handle invalid inputs, such as entering a non-existent tax number or an invalid time. So the program is a simple and yet effective to-do list manager that ensures a smooth user experience. It focuses on essential features like adding, viewing and updating tasks, while incorporating flexibility for handling time in various formats. It emphasizes user-friendliness by validating inputs and also providing clear feedback, making it a practical tool for organizing daily activities.
Alright people, so for this to-do list console application, we are going to be importing a module called datetime, and then this is to essentially add time to our various tasks. Here we are creating a function called bright, and then within this function we have an empty task list which stores our tasks and then its details. Over here we have an infinite loop printing out or displaying the menu on the terminal. Here the user is prompted to enter the choice from the menu that has been shown to him. This program has been structured into multiple if blocks where the user enters either of these options, it matches it to the corresponding operation. So we have, for the first one, if choice is equal to 1, meaning to say if the user wants to add task, then this code is responsible for executing the task. The same for this, else if choice is equal to 2, and so on. Lastly, we have if name is equal to main, then we call the bright function, and then what this does is to literally execute these lines of code or this program as an independent program and not as an imported one. So literally this is the main structure and flow of our program.
Here, starting the task creation process, the program checks if the user's choice is 1. Yes, presumably an option for adding tasks. It then prompts the user to input how many tasks they want to add. This input is converted into an integer. So looking at this, you could see that yes, number of just tasks. And here, a loop, runs number of tasks, times, allowing the users to input multiple tasks. For each task, the user is prompted to enter a description of the task. The created time is captured using the current date and also time, formatted as a string. Yes, you could see that you have to input, task time. The program asks the user to enter a time for the task. That is the example: 5 p.m., 5:30 p.m. and 9 a.m. While a loop ensures that the user keeps trying until they input a valid point. The input time is checked and also converted. If the input contains a column, it assumes to be in the format of this particular 24 hour format or in 12-hour format. So if the input doesn't contain a column, it assumes to be in the format form, which is 5 p.m. and 9 a.m. The program attempts to also pass the time using the date time. yes, script time and based on the format, and then also convert it to a 12-hour format. So it also ensures lower cases, also formatting. If the time format is incorrect, the user enters something unrecognized. So just assume that yes, a value error is raised and the user is prompted again. So once a valid tax and time are entered, the tax is added to the tax list, which is also presumably defined elsewhere in the program. So the tax is stored as dictionary with the tax description done, a flag to also indicate if the tax is done initially false, created at, so the timestamp when the tax was created, done at the timestamp when the tax is marked as done. Initially it's going to be marked as none. Okay, so tax time, the time the tax is scheduled to be completed. So formatting the creating, for this you have to, the created time is converted back into a date time object. And here, if the tax was created today, it also displays the creation time as today at. So if the tax was created on a different day, it displays the creation time in the format. So you could see that the confirmation message is printed, indicating when the tax was also created and when it is scheduled to be completed. The user chooses option 1 to add a tax.
Next, we are going to be looking at how the program displays the tasks that have been added by the user. When the user selects option 2, the program first checks to see if there are any tasks available. If there aren't any, it prints no tasks available as seen in this line. But if there are, it uses the enumerate function to loop through and gather information about the task. So it gathers information such as the status of the task, whether the task is done or not done. It gathers timestamps also, when the task was created, when it's scheduled for, and the time the task is done, or when the task was finished. And after that, it prints all this information for the user to see. And a short illustration of this function would be this. Select option 2 and the various tasks that have been added are shown here. You can see the status of the task. All of them are not done. It was created at this time, scheduled for this time, and since none of them are done yet, there's no completion time yet, so it says not done yet.
So my name is Apia Ejejesi, and my work here to take you through the third point, which is mark task as done, which starts from line 78. So from here, it's from the user to enter the thought. If the user enters the task, which is what? Mark task as done, that's number 3. So from here, from line 79, if there's no task, then the program will print no task to be marked as done. Else, so let's come to what? Line 72. Else, if there are tasks available, this line prompts the user to enter the task number they wish to be marked as done. And from our code, you can input a number of taxes. So if maybe the user picks, we want to mark tax, which is number 2 as done, that you click on and input that tax there. So going to the next line, which is if 0, that is number what? Line 83. This line checks if the provided tax index is valid, meaning it falls within the range of existing tax. It could be from 0 to the length of the tax listed. If index is valid, this code inside this block will be executed. But if it's not valid, then it won't be executed. So from line 84, this line updates the selected tax by setting the tax as done to the true key. This indicates that the tasks have been not completed. This line 85. This line captures the current date and time in a specific Spring format. and these string formats have been indicated here, right? Using the date model, this timestamp will be used to record when the task was marked as done. That was the usefulness of that part of the code. Then let's go to the next one, which is line 86. This records the time when the task was marked done. This line updates the selected task dictionary by setting the done at key to the previous captured done time. Right? So this is the previous captured done time, which is located here. Moving to the next code, which is on line 89. So this line 89, right? So line 89 converts the done time string back into the datetime object for easy manipulation and formatting. So that's the usefulness of that part of the code. So if done.dt.time, so that part of the code, which is line 90. So this line checks if the date part of the done _dt, the time the task was marked done, is the same as the current time, the current date. This is used to determine how to format the output message. That's the usefulness of that part of the code. Moving to line 91. Format time, formatted _done _time. If the done date matches, the task was marked done. This line formats the done _date into a more useful, user-friendly string that indicates the task was completed today, using the format today. Using the format today at HH, indicating the hour, minute, and the AM or PM, whether it's in AM or in PM. Else, then moving to line 92, else. So this part of the code formatted _done _time is equal to done.t. So that part of the code, if the date do not match, this line format the done _time into a string that includes the full date and time, using the format given as the year, month, date, at, the hour, minute, either it's AM or PM. That part of the code does that work. Moving to the next part of the code. So if it's true there, then it should give us to mark as what? It should mark task as done. If not, it should print. Else, it should print invalid task. So basically, all this part of the code, which is from line 78 to 97, allows the user to mark the task as done.
Alright, this time around we want to remove tasks. That's 4 on the menu, option 4. Alright, so let's move on to the block of code that controls that. Alright, so we are saying that if the user's choice is 4, we are saying if not tasks, print no tasks. So what this is essentially doing is that if there are no tasks in our task list, we should print, or we should show this on the terminal, no tasks to delete. Else, we want to ask the user to input the task number, right? And then we are converting it into an integer. Now, the reason why we are subtracting 1 from it is that, let's say the user wants to refer to the first index, and then in Python the first index is 0. So when the user inputs 1, in Python the first index is 0, and then the second index is 1. So if, let's say, the user wants to delete the first one and then puts in 1, if we don't subtract 1 from it, it will delete the second number, which isn't user friendly. It doesn't correspond or correlate with what the user wants to do. So that's the essence of this -1 here. And then here we are checking if the task number the user placed or typed into the program is within 0 to the length of the task. And then if it matches, then we delete the task. So in the task list we have we'll have task.pop, which means that at that index in the task, it should remove the task we want to delete. All right, then we print task and then rename the task from the dictionary is deleted. All right, else we should print invalid task number. Great, so let's test this out. Okay, so option 2, show tasks. So these are the tasks that we have. So 4, let's delete task. So here I want to delete task 2, so I'll put in 2, enter the task number to delete 2, and then it prints task 8 deleted, meaning that this is deleted. So when we show the task 1 again, which is option 2, it does away with the 8 task. Right, that's great. And then finally, option 5 is just to exit the application. So print exiting to-do list application, and then you break. Else print invalid choice, please try again. That's to just work on if it is an error, the user should try again. So let's also try that one out. 5, exit, so exiting the to-do list, and then that's it. All right, so yeah, basically that's that. All right, so it prints invalid choice, please try again, and that's from this part of the code. And as stated earlier, this set of code is to allow or make this program run independently and not as an imported file or imported program. All right, thank you very much.